should start on YouTube. Let me check. And I see some familiar names in the list. Hi. Okay. YouTube works. And now I'm going to share this nice slide I have, just so people know. Okay. I think we're good to go. Is everything all right? Quint, are you here?
Yep, I'm here. Can you hear me?
Yes. Please, someone from the attendees confirm that you can hear us well and that you can see us right now, because we're doing it for the first time in our lives.
We have a confirmation.
Cool.
Well, thanks, everybody.
Thank you. So, hello, everyone. Welcome to the WebCore meetup. My name is Max. I'm the organizer of this event, and I'm joined here by Quint. Quint, say hi. Quint is another organizer. He will be our host tonight. And this young gentleman here is Simon Pieters, who will be our one of our speakers today.
Hi, everyone.
I see some familiar names in the list, which is really great to see. Well, welcome back. I also see quite a few new names on the list, and well, the reason for it, one of the reasons for it, is that this is actually our first online edition of this meetup. Normally, we're just hosting offline cozy gatherings somewhere in the middle of Amsterdam. And well, this time it's a bit unusual online settings, but it actually allowed us to invite people from all other countries, and including Simon, who is joining from Sweden. So yeah, special welcome for everyone from outside of the Netherlands. It's great to have you here. Now, for those who are new, we just tell real quick what WebCore is about. We're an Amsterdam-based meetup. We are focusing on core web technologies. And by core technologies, we mean everything in the web stack beyond the frameworks, libraries, and programming languages. Well, I guess JavaScript is an exception because you can't talk front end without JavaScript. But we gather a couple of times a year, not so often actually, but we're trying to invite speakers who work directly with the things they're talking about. So you get the presentations firsthand. So for example, last time we had Rafael Cuba da Costa, who is an engineer from Chromium team, and he's with us today actually. He was talking about hardware API in the browser. And before that, we had Andrew Betts talking about feature policies. And this time is no exception, but more about it later. So another thing I want to mention now, since, well, this edition, we have a code of conduct. You can find it on our website. It's also linked from our meetup page. There is nothing really special there, but basically we expect everyone, all participants, to follow the rules, be nice and respectful to each other. And we organizers, we will try to make sure that everyone feels comfortable. And if you have any problems, you can always reach out to us and we will help you. Yeah, so with this, I want to just welcome you all once again, and I will give floor to Quint, who will say a few words about the agenda and everything else. Yeah, so Quint, please.
Hi. Yeah, it's really exciting to see everybody here. You know, we planned this and we have lots of international guests. So yeah, thanks a lot for joining us. With Corona, it's on the one hand nice to have such a nice wide reach. But on the other hand, it's kind of a shame that we can't get together in person over drinks. So usually our meetups are in person, and I think we'll try to do them online some in the future. But for now, here we are. If you do find yourself in Amsterdam and after all of this, come join us for a physical meetup. Everyone's welcome. So for the agenda, now we're just giving some introduction, but soon we'll have a talk from Simon first about how you can improve the web platform, about interoperability. I'll introduce him a bit and we'll talk about that. And then after that, at around 7:50-ish, I guess Amsterdam time, we'll have a talk from Max himself about the Zen of cookies, a topic very, I don't know if I would say near and dear to my heart, but it's certainly something we deal with a lot at where I work. So after each of the talks, we'll have some time for Q&A, and I'll talk about that in a minute. But after both of the talks, we'll have a web platform quiz, very popular from last time. Just some goofy questions about some very goofy behavior in all around the web platform. Some of them with JavaScript, ECMAScript, but others with just all sorts of interesting edge cases. This was very popular last time, so it's nice to have it back. And there are prizes involved with that quiz, and we do ship internationally. So yeah, you might get something out of that. And then we'll kind of close it off around 8:30-ish. But if we go over a little bit, it's okay. Let's see. So after each of the talks, we'll have a bit of a Q&A. The way that works is for participants in Zoom, which right now it looks like most of you are in Zoom. We have 20 in Zoom and 8 on YouTube. So for the participants in Zoom, there's a tab in Zoom, the Q&A tab. And so over the course of the talk, you'll have the opportunity to just kind of type whatever you like, whenever you like, as a question to our speakers or kind of anyone in either of them at any time, honestly. And then you can upvote other people's questions that are interesting to you. So if we're short on time, we'll get to the most popular questions from Zoom. But if there are more questions and we have some more time, we'll try to get to as many of them as we can. If there's something wrong with Zoom or you're on YouTube or you're having some other trouble, you can also ask in the chat. I'm trying to keep an eye on those. And you could also use that to ask us any questions, or if our levels are bad, just tell us. Hopefully we'll be able to fix it. So we have the YouTube mirror. The link to that is on the main WebCore page, webcore.group. We have a meetup page that also has all of the information for this meetup and future meetups. And yeah, so if you're on YouTube and you want to be on Zoom, you can find the link there. If you want to instead watch on your couch, that's also an option. And I think that's it for operational stuff. Max, anything to add?
No, I think you pretty much covered it.
Okay. All right, and yeah, feel free to ask questions and stuff in chat if you have some issue with the stream. I'll be here watching. So first up on the docket is Simon Pieters. So Simon is going to be talking about how you can improve the web platform, about some interoperability questions, and what happens if you find a browser bug, which is something that we at my work do a heck of a lot. So he works at he's a contributor to the WHAT working group, to the HTML standard. And he's worked for the last decade or so on web interoperability, research, standards, testing. He works at Bocoup, and they make the Test 262 suite, as well as the web platform tests. They do a lot for both of those projects, as well as the ARIA screen reading standards and kind of where the development for this will go. So they do really important web work. All right, so without further ado, I'll give the floor to Simon.
Thank you for that introduction, Quint. So hi, everyone. Let me try to share my screen. I can't share my screen. Do you need to give me the highlights or whatever it's called in Zoom? Now I have Spotlight.
Yeah, just did.
Okay, let me try again. Okay, I need to stop sharing.
Yeah. Yeah, this works.
Okay. So today I'm going to talk about how you can improve the web platform. So first, let's discuss why you would want to do that. And my focus here is interoperability. And I define that as browsers doing the same thing for the same piece of code. I hope that's clear enough. But for example, if you have a list element in HTML then it should render the same in Firefox as it does in Safari or Chrome. Last year, there was a survey from MDN called Developer Needs Assessment. And one of the things that was identified as a top pain point for web developers was interoperability. So what you'll learn from this talk, I will discuss how to practically investigate a browser bug, how to use HTTP archive for web compatibility research, how to find the right people in browser engine projects, how to write a web platform test, and briefly how to go about changing a spec at the W3C or the WHATWG. So who am I? I started contributing to the WHATWG in 2005. One of my first proposals was the short doc type that everyone is using today. I worked at Opera Software on quality assurance and web standards between 2007 and 2017. Some of the features that I worked on was the video element, web workers, WebSocket, and more recently the picture element. I am one of the editors of the WHATWG HTML standard. Currently, I work at Bocoup, which is a web consultancy firm. We're currently focusing on accessibility and InfoSec standards and rendering interoperability, at least the stuff that I'm working on. I'm also working on a book called Idiosyncrasies of the HTML parser. This is currently a work in progress, but it's free to read if you like. You can check my Twitter if you want to find a link to this book. Okay, so how do you investigate a bug? Let's say that you have a web page that you are working on or that you just using, and you find that it renders differently in 2 different browsers. One obvious approach is to use DevTools or whatever you usually use to debug a problem to find the thing that is being different between browsers. Another way that is kind of the traditional way that doesn't always work, but sometimes it does, is to just remove code until the bug doesn't reproduce anymore, and then take a step back and remove a little bit less. The end goal is to end up with a minimized demo. So a demo here is like a test case, but it doesn't necessarily have a pass condition. So it doesn't say which behavior is the right one, but it still reproduces the bug that you're interested in. There's a page on MDN that goes through how to reduce test cases. So here's an example of a demo. I have 4 select elements and apply some different styles to them. The first one is without any styles at all. And then you have 1 pixel solid border and 2 pixel solid border, and then -WebKit -appearance none. And the link at the top loads this demo in a tool called Live DOM Viewer, which is a tool that Ian Hickson developed while he was specifying the HTML parser in the HTML standard. So what's the result of loading this page in different browsers? Here are some screenshots that I took. In Safari, you have the native select style for the first 2 cases, and then a different style for the 2 pixel solid border, and then a third style again with WebKit appearance none. And as you can see, all of these 4 cases in Safari have rounded borders. In Firefox, the result is different. The second case no longer has the native style, but instead has a Windows 95 style drop-down button. And the WebKit appearance none case doesn't have rounded borders. And then in Chrome and Edge, we see a few different results depending on the version. So they recently made a change to how form controls look to be more modern and more stylable. And this changed the default styles as well. You can see that in Chrome 83 and 85, the WebKit appearance none case doesn't have rounded borders. But in Chrome 81, it did have rounded borders, and the background color is different as well. One minor difference in Edge compared to recent Chrome is that Edge maintains a slight border radius in all cases, whereas in recent Chrome, only the first unstyled case has a border radius. So this is an example of lacking interoperability between browsers. So let's talk about a principle that browser engines and standards projects have when making changes to the web or the web platform, and that is essentially don't break the web. There's a document called HTML Design Principles from the W3C, and one of the principles is support existing content. And from the Blink project, they have a document called Blink Principles of Web Compatibility. And I'd like to read this quote because I think it kind of drives the point home a bit. There are around 771 billion web pages viewed in Chrome every month, not counting other Chromium-based browsers. So seriously breaking even 0.0001% still results in someone being frustrated every 3 seconds, and so not to be taken lightly. So the reason browsers don't want to break the web, essentially, is that not only that their users will be annoyed, but also if a page works in one browser and not in the other browser, that gives users an incentive to switch to the other browser that works. And that's why browsers normally don't want to break things that work. So how do you find out if something would break? There's a project called HTTP Archive that I have used quite a lot. This project tracks how the web is built. Twice a month, it crawls 5 million web pages and includes the full response bodies of the HTML and the CSS and the JavaScript, and also other data about these web pages. And then there's a tutorial for how to get started with HTTP Archive using the BigQuery tool. This should be accessible from httparchive.org. So here's an example of something that HTTP Archive collects: the total web page size of the median web page. So as you can see, it's been increasing over time. And on desktop, the median web page weighs about 2 megabytes. And on mobile, it's 1.8 megabytes. So that's kind of depressing and also impressive, depending on how you see it. But usually I'm more interested in diving deep into the response bodies because I'm looking for something very specific. So for example, when I worked on the WebKit appearance CSS property, I want to know which values web pages use. So you can use BigQuery and write an SQL query and extract with a regexp the values for WebKit appearance, and then group them together and count how many pages match. So what is the result of this query? This is a fraction of the full table, but the most common value is the none value, so WebKit-appearance:none. And then the second most value is the button value, which is used roughly the same amount as none. And then it goes down from there. But for example, a browser would need to support the checkbox value, because if it doesn't support that value, it will probably break web pages that expect that value to work. So in the CSS appearance spec, it tries to simplify how the appearance property works, but it has a list of compat values that map to the auto keyword, so it has the same behavior. And checkbox is one of those compat values. So the idea is web pages that use WebKit appearance checkbox would act as if they actually used appearance:auto. Okay, so let's say you want to make a change in browsers. How would you find the right people for the different browsers? Well, first, you need to realize that the different browsers have an underlying rendering engine, and those are open source projects, at least for those that are being actively maintained today. Those are Gecko, WebKit, and Chromium. One approach to finding a person behind the code is to get the code and then find the implementation of the feature that you're interested in. And depending on if the project uses Git, or I think Gecko uses HG, but the principle is the same. You look at the version history to see who has touched the implementation. There's a problem with this though, because there are often changes that are unrelated to the code at hand, because maybe there's a reformatting change or something. So you need to look at the commit and maybe go further back in history to see who actually implemented the change. Another approach is to look at the public bug trackers for these projects and search for bugs that have been fixed for the feature, and who was the assignee and who was the reviewer. Those are probably people who know about the feature. And then these projects typically also have API owners, or WebKit has reviewers. For Mozilla, there's a wiki page that lists the various people for different modules. And for Chromium, in the source code, there are owners files with people responsible for that piece of, or that API. So it's easy to get a long list of people that you could email, but keep in mind that they don't have any obligation to respond to anyone in particular that asks things of them. So I was advised to keep your message short, and if there's a public issue, link to it with more information. And also say why you're contacting them in particular. For example, if they fixed a bug, you can link to that bug. And also, I think it's nice to limit yourself to one person from each project and say, if you're not the right person, please forward to someone who is. And again, you might not get any response, but allow 1 week to pass and see if they respond. Another approach is to reach for a wider audience within these projects. There are different ways to do this. One way is to file a new issue. These projects also have discussion groups or mailing lists and have like a catch-all entry points usually. And they also have Slack or IRC where you can ask questions. Okay, so let's switch to web platform tests. This is a shared test suite, primarily for browser engines, but also for other projects that implement the web platform, such as JSDOM, Node.js, and recent Deno. I think I'll use web platform tests for some of their APIs. There's a documentation site for how to use web platform tests with all of its, how to write a test essentially and how it's structured. So most of these tests are automated and there are different kinds of tests, but here I'm only going to talk about the JavaScript kind. So there's a harness called test-harness.js in web platform tests. And this is an example test testing the appearance property using test-harness.js. So this harness provides the test function and also the assert equals function, and also has support for asynchronous tests or promise tests, and has lots of other assertion functions and such. But in this case, the test creates a normal input element and sets the style attributes to appearance : none. Note that it's not using the WebKit prefix in this test. And then it asserts that get property value for appearance is the string none. And if it is, it will pass the test. Otherwise, it will throw an exception at this point and fail the test. WPT.FYI is a website that shows test results for every automated test in web platform tests in different browsers. So here we see the test results for this test in Chrome Dev 84, Edge Dev 84, Firefox Nightly 78, and Safari Tech Preview 106. And since the test wasn't using the WebKit prefix, it only passes in Chrome and Edge, where this change was just landed in for M84, so version 84. Hopefully it will start to pass in Firefox and Safari as well, but we can use this this page on wpt.fyi to track progress. So let's say that you have a feature that you want to test. It's often not enough to just write a single test. You need to have reasonable test coverage. So one way to do that is to start out with a testing plan. And in the WPT docs, there's a page called Making a Testing Plan that's explains how to do this well. Essentially, you start out by reading the spec and try to enumerate all possible things to test. However, all cases that are possible to test often is an infinitely long list. So you need to constrain yourself and exclude things that are not interesting to test. This page also explains how to approach finding existing tests, which can be a bit difficult because the web platform is large. Okay, so let's say that you have investigated a bug, you have written a test, now you want to change the spec. First things first, you need to make sure that you have the intellectual property rights cleared. And this is because the web platform should be royalty-free. So anyone suggesting changes needs to sign a CLA or join a working group, depending on if it's W3C or the WHATWG. It either needs to be you personally or your employer. Assuming that's out of the way, the first step I would recommend is try to build the spec locally. Different specs have different tools to generate the actual spec. Most CSS specs and WHATWG specs use a tool called BikeShed. Some other W3C specs use a tool called respec, which is running in the browser as JavaScript, so you don't need to install anything to use that. For the WHATWG HTML standard, it has a custom build step, and this is in a repository called HTML-build. Then you would want to try to follow the specs formatting conventions. And this is usually documented in the repo in a contributing file or README or so. Otherwise, you can try to look at the surrounding markup and use the same convention. And then you make your change and submit a pull request like any other open source project. In your PR, you should link to the tests, if there are tests. And then you can ask implementers and spec editors to review your change and follow up to address review comments. And hopefully you can land your change. There's more to it than this, but this is technically what you need to do. There are things to keep in mind about how to read a spec and how to write a spec. So if you want to learn more about how to read a spec and how to write a spec, and essentially everything that I've talked about in this talk is covered in an online book that Bocoup is announcing today. It's at wpc.guide. So you can be the first to read it if you are interested in this. And that's it. You can follow me on Twitter if you like. And we can go to Q&A.
Yeah, thanks so much, Simon, for the talk.
Thank you.
So we now have the Q&A open on Zoom. So if anyone would like to ask a question, we have a couple already. Yeah, just type it in. I think there was one quite a while ago from Igor. He asks, they ask, why would I want to create web platform tests? What's in it for me as a developer? So what can a developer gain by using one of these test suites?
That's a very good question. So I think the answer is that it's more likely that the bug will be fixed if it has a good test. And also for spec changes, if you want to get a spec change landed, at least in the WHATWG, but also in many working groups at the W3C, they have a policy that requires tests to land a spec change. But the reason for that policy is exactly that it's more likely that browsers will notice that something changed because now they see that they have a new failing test, essentially, and that's part of their CI system. When a spec changes, they might not notice for maybe a few years or 10 years. If you write a test, they might notice within weeks and hopefully fix the bug. So I think that's the selling point for writing tests. It shortens the time to get things fixed and reach interoperability in browsers.
Great. So it's a way to, tests are kind of a means to an end for changing the web platform in a way that we can more,
much like
precisely
the
identify.
specification itself is also a means to an end. The goal shouldn't be to have a specification. The goal should be to have something usable in web browsers, and how to reach there is through standards and tests, at least if you want interoperability.
Like a good open web platform.
Yeah.
Let's see. So we have another question from an anonymous asker, somewhat shy, I suppose. How long does it take for a fix for a specification to land in an actual browser?
It depends is the short answer. The longer answer is I've seen trivial changes go from specification issue to the spec being fixed, there being a test, and browsers being interoperable, at least for the nightly versions, in less than a month. I shared this on Twitter the other day. Let's see if I can find this. Yeah, it was the case sensitivity of the target attribute, or the equivalent feature for window.open. So this was filed as a spec issue in March 2017. And then we researched HTTP archive, and Chris Dumas is a WebKit implementer. T-Kent is a Google implementer. They agreed with the change, and I filed bugs, and they were fixed in less than a month. So this is a fast case. It's more common that it takes around a year, but it can also take like 10 years. It depends a lot on what the change is. But if someone does the heavy lifting by following the process that I outlined in this talk, that should quicken up or lower the barrier for browsers to go ahead and fix the issue.
So I'm actually interested, I have my own quick question here. You mentioned that there are these different implementers for these different browser engines. Yep. How often does it come up that they actually don't agree on either a particular implementation or a particular spec fix? So if someone points out, hey, this is an issue, what if, I don't know, a Chromium dev says works as intended, and the Firefox, the Gecko people and the Edge people are unhappy with that? Is there some sort of way to resolve that, or does it happen ever?
It does happen. It happens pretty often, actually. that they disagree. And usually it's the spec editor's job to try to resolve that issue. But if there's a person driving a change, they can also try themselves to resolve issues like this. But I would say that it's the spec editor's job first to resolve such issues. One example where that has happened is with the Shadow DOM, I think, has various disagreements between different browser projects on how the feature should work. Yeah, I don't have enough inside knowledge of Shadow DOM, and I wouldn't be able to explain it in a short amount of time either. But it's one example where browser projects disagree on how something should work.
Excellent. I think that's probably it for the Q&A of this talk. So I'd like to thank Simon again for joining us. And
thank you.
Yeah, it's an excellent talk. It's always fun to see the insides of how this kind of thing works.
Cool.
And I'd like to say that if someone comes up with a question during the next talk, well, just feel free to drop it in the Q&A, because I believe Simon is not going anywhere until the end, so he'll be around to answer the question.
Yeah.
Yeah. Great. So that's our first talk. We actually have a second talk on the docket today, and that's from Max. So I want to welcome everybody who's just joined. We're live on Zoom as a Zoom webinar. That's probably the best way to join us. But we also have a mirror on YouTube Live. We're keeping an eye on the chat for these. Our Zoom chat is currently disabled because of some deficiencies in Zoom's moderation interface. But in the meantime, we have the Q&A section still open. So if you have any questions, pop them up. I see another question about links. So we'll have each individual talk will have a video, and we'll have all of the slides and things available for you after the fact. You can find these on the WebCore group page. So that's webcore.group. That'll link you to the meetup page where you can see this particular event, which has all of the information. And I think, yeah, we should have it on the site as well.
I can also drop a link to the slides in Zoom, if that's okay.
That'd be great.
Yeah,
absolutely. And so if you're on Zoom, you should be able to see it there. All right. So next up, my colleague Max will be giving a talk. So Max works with me. We work on a co-browsing proxy. It's called Surfleet. It has some interesting web corner cases, which is what made us eventually start WebCore. It's a fun opportunity to talk to people about the kind of things that otherwise it's only our eyes that see this kind of craziness. So Max has been working on the web for quite a while. Before, he worked as a security researcher and sort of poked and prodded at things in kind of the same way that he does now at Surfleet with me. Yeah, so he's interested in this kind of standardization, this testing as well. But our focus is on the more practical proxying, and we have to emulate some browser functionality. So Max is often looking at, okay, how are browsers doing things, and how should we react if a site asks to do one thing or another. So yeah, without further ado, Max is going to talk to us about one of these issues in particular, namely cookies. So the Zen of cookies. Max, you have the floor.
Yeah, thank you, Quinn. That was a much longer introduction than for Simon.
I know you a little bit better.
Thank you. Okay, so I need to actually spotlight myself right now. Okay, so and then I can share this screen like this. So you should be seeing this right now. Right. So I'm going to talk about cookies today. And yeah, so let me just first introduce myself again, very shortly. My name is Max. I'm originally from Russia. I'm living in the Netherlands right now. And I work with Surfly, where, well, we're working on the sandboxing proxy. So it's a great place to be if you're like me, if you love the web, and if you're ready to learn it the hard way. And one of the things that I've been working very closely in the last few years is cookies. So cookies are, as I learned, they are ancient. The first RFC was introduced in 1994, I believe. They're also sophisticated. There is a lot of intricate details to them. And actually sometimes so much that they just don't make sense. And in this sense, cookies kind of remind me of this thing called Zen Buddhism, which, well, hence the name of this talk. So, and this talk is going to be basically just a collection of pitfalls and examples to kind of prove this statement that cookies are like Zen. Because, well, I mean, there are much more clever people than me working on cookies standard in web standard space. But us ordinary web developers, we don't get to deal with corner cases so much. So when we do, like for example, if you need to implement a GDPR compliance, like some cookie wall solution or something, well, we often get nasty surprises. And so another goal of this talk, I guess, is to kind of raise awareness about this trickiness. So hopefully it will be a heads up for folks out there. And well, finally, I think some people might just find it fun, just like I did. And yeah, so let's get to it. So this is how MDN defines cookies. It's a small piece of data that the server sends to the user browser, and browser can store it and send it back. So basically, we're introducing state into a stateless HTTP protocol. And well, I'm assuming everyone knows this to some extent already, but for the sake of this talk, let's just extract a few facts about cookies. Fact number one, cookies can be set with set cookie response header or JavaScript API, namely document.cookie. Fact number two, cookies require special string format when setting. And three, browsers send cookies back to the site that has set them. And finally, fact number four, well, everyone knows it, that cookies are giving you the best online experience. Man, making jokes to an online audience is weird. So if we rephrase this, what it really means to us developers is cookies are most often than not sensitive. So they should be protected, and you don't want to leak them in most cases. So I suggest to we make these four facts our agenda for today, because each of these points is a rabbit hole of its own if you look closely enough. And starting with the first one, so let's just start by saying that set cookie header and document domain are not the only ways to set a cookie. We have browser extensions, and browser extensions have this pretty powerful cookie API. It is asynchronous. It pretty much solves all the usability problems that document cookie has, and it's actually great, and it's much more powerful. But to have this power, unfortunately, you have to have an extension installed in the user browser, which is not necessarily simple. Another way to set a cookie is this. Now, I think most of the people, they don't really have never heard about this, but there's actually this special meta tag that you can use in HTML to kind of emulate the HTTP headers, and you can set a cookie with this. Now, this feature has been actually removed in Chrome and Firefox, well, not so long ago, just last year. So you can't really use it on the web right now. But, well, you know, some browsers still support it. Yeah. So let's talk about JavaScript, right? So you can use document.cookie. It's a JavaScript API to read and set cookies. And apart from the fact that it is synchronous, so it actually introduces quite a lot of performance problems, it's also quite peculiar in a way that, well, just look at it. So the setter is actually using completely different format as the getter. It's string format, but the actual values are very different. And the value of the return value of a setter, it seems like it's always the same as you have set, so it's completely useless, and it doesn't raise any errors if you provide some malformed data. So, for example, if you want to verify if your cookie has been actually set, the only way to do that is to read it again, parse that different format, and then check if the cookie is there. And this inconsistency actually causes a very interesting problem. So look at the getter format. This is the same format as you will see in the cookie header in the request. And if you think about it, once a cookie has been set, this is the only information your web application will ever get back. So just the name and the value of all the cookies. So if you ever want to check the, for example, an expiration date on a cookie, of existing cookie, or its path or domain, there's just no way to do that. You just need to know it in advance. And this creates, so for example, let's say if you have a cookie that has been set, for example, some library, Google Analytics. So you're reading the cookie, it says cat equals dead. Let's say we want this cat to be alive, and we are overwriting this cookie like this. Then we read it again, and we end up with 2 cats. Why? Because the first cookie was set with the domain attribute. So this domain attribute actually changes the scope of these cookies. And when we try to override it here, we actually created a new cookie with the same name. But unless you know how the initial cookie has been set, with which particular attributes, you have no reliable way to override it. And well, you just need to know it. So as weird as it seems, even if you have full control over your web application, you don't really have full control over its cookies. You can do this with a browser extension, but again, that's not always possible. Going to the next step, let's look at the setter format, right? So you have seen this before, probably, and well, this is actually quite nice, right? So you can look at it, you can read it, you understand what it does, but you know, human readable is almost always the opposite of machine readable. So the problem is that this exact cookie could be set by hundreds of different ways. Like, for example, you could do this. This leading dot in domain attribute doesn't actually change the semantics. And you can play with white spaces, add them almost everywhere, remove them. You can play with character case and get creative with some values. Or you can even get on the bleeding edge of the technology and use cookie prefixes. This is my favorite because it's like an AI of the cookie standard. So there are reserved cookie name prefixes that browsers respect. And for example, this one, you wouldn't be able to use it without a secure flag because browser will not allow you to. So, and we didn't even get to the obviously wrong, but well, still valid formats like this or like this. Notice the multiple path attribute. So there is quite a few places to get confused. And if you're curious, there is a very nice research by Van Nikulin over here. He is comparing the parsing differences in different browsers. And well, believe me, it's quite a mess over there. So at this point, you might think, okay, parsing is very tricky. I shouldn't do it myself. But surely enough, every decent programming language has a library that does it, right? And you would be right. There are hundreds of implementations over there. But the problem is that they're all wrong. Or they're all right, depending on how you look at it. So for example, Python has this built-in HTTP cookie module that can parse set cookie format. But as long as you start passing something not very standard, like this, it falls short. So for example, this string here, it would be interpreted by a browser as a single cookie named A, and everything else would be its value. But this library interprets it as 3 different cookies. And so imagine if you start using this library in some kind of HTTP proxy. So you would be quickly messing up the responses and possibly even introducing vulnerabilities in your application. Another example is cookie folding. So actually in the earlier standard, this was allowed. So you could set multiple cookies in a single set cookie header, divided by commas. So this is not supported anymore, but Safari was supporting it up until 2 years ago, up until macOS Sierra. And you can still see it in the latest dev tools in Safari. This header would show up like this. So as if there were 3 different cookies set. And well, even though only the first one would be actually set and stored. But so now, what I'm saying, nowadays, major browsers don't support this anymore, but the problem is that library implementations still do. I would dare to say that most of them still do, because at some point it was allowed actually, but they never changed the implementation. And if you Google, there are quite a few bug bounty reports with real vulnerabilities exploiting this cookie folding. So parsing is very tricky. And let's just look at a few interesting examples. So did you know that you could have a cookie with an empty name? So this one here is an empty cookie with an empty name and a smile, and it would show up without an equal sign in a cookie header. You can of course have a cookie with an empty value. That's okay. You can use special characters in most of the cases. Cat exclamation mark is a valid name. You can use equal sign multiple times. In this case, this is a single cookie named A, and B equals C, etc. is its value. Sorry, and you can use white spaces, as we told before. And finally, you can play with encodings. So the current standard actually allows only a subset of ASCII in the cookie value. However, most browsers actually allow Unicode, like UTF-8. And so this is the difference between actual implementation and the spec. And there is a work going on to actually change the spec to conform with actual de facto standards. Even though, well, I would say that this is weird by itself because you don't normally see Unicode characters inside HTTP headers. But anyways, so this brings us to the next stop. Browsers send cookies back. So what I'm going to talk about here is cookie scope. Cookies have these attributes, and name, path, and domain are special because they define the cookie's identity, which means that all these cookies here, despite they all have one and the same name, but because they have different combination of path and domain, they're all considered different cookies. So this page here would actually receive all of them at once. And as we told before, the server would have no idea how to distinguish between those cookies because all it gets is names and values. An interesting thing is that the order of the cookies in the cookie header is actually defined. There is an algorithm, but it's quite complicated and counterintuitive, so I wouldn't really rely on that because why? So going on, we know that the cookie scope is defined by the URL, right? So this page here would see the first cookie, the oatmeal, but not the chocolate cookie because the path doesn't match, right? So this is okay, reasonable. So what if we do this? We change the document URL with history API, just like single page applications do, right? So the document URL will change, but should the cookie change? Should this practically the same page, should it see different cookies? And the answer is it actually shouldn't. So this kind of reveals that document URL and cookie URL are different things for a browser. And yeah, so the cookie contents will not change. However, if you thought that it should have changed, you're right too, because in some browsers, it's actually, it would be changed. So, okay, so now we know that document URL and cookie URL are different things. Let's go deeper. What do you think the behavior of cookies will be inside these iframes? So you have a few empty iframes, insert CDoc, and a few special schemes, blob URLs, file, and data URLs. And well, don't even try to guess. There is no correct answer. All the browsers think differently. So sometimes they would inherit the parent scope, so the scope of the embedding document. Sometimes they would just simply ignore cookies inside these iframes. And in this case, in case of data URL, Chrome even raises exception when you try to set a cookie. And this is actually the only case that I know that where you actually get an actual exception when you start to set a cookie. So it's like a Wild West, really. Speaking of compatibility problems. And this brings us to the last topic, which is security and privacy. Now, this is a very broad topic. Like, I mean, even defining what privacy means with regards to cookies is very difficult. You might know that each browser has its own approach to tracking cookies, for example. And the definition of tracking cookies is different per browser. So Safari has this intelligent AI-backed ITP system, and Firefox seems to use like blacklists, whitelists of trackers, etc. So it's a broad topic, but I do want to touch upon a few things that I think are very good to know for every web developer. And first of which is weak integrity. So consider this. Any page can set a cookie with any arbitrary path. So if this page sets this cookie, then Jimmy will not actually see this cookie back, but Chuck will see it on every subsequent request. Which, so the takeaway here is that, well, path, even though it's kind of isolating cookies, but it shouldn't be considered a security boundary because you can still override other paths. Same with domains. Domains can set cookies on any subdomain of theirs. So google.com can set cookies on mail.google.com. And if this looks okay to you, so consider this. GitHub.io, if you use GitHub Pages, GitHub.io can set cookies on any actual GitHub Pages domain. But it gets better. myevilapp.herokuapp.com could set cookies for all other herokuapp.com domains just by setting this domain to a super super domain, so to say. So this would affect all other Heroku apps if herokuapp.com was not a public suffix. So actually, Heroku is specifically safe to use, but not because cookies are safe, but because Heroku did steps to make it so. So herokuapp.com is actually not a domain of its own, but it's just like .com or .co.uk. It's a public suffix, a top-level domain that you cannot use by its own. And that's what's saving us. But if you're ever offered your own subdomain on some random hosting, well, this might not be the best idea, actually, both for you and for this random hosting, for that reason. As an icing on the cake, insecure, unencrypted HTTP pages can override secure cookies that were set by HTTPS pages earlier. So secure cookies are actually secure in a very narrow and specific way. So you should keep that in mind. HTTP-only cookies, luckily, cannot be overridden from JavaScript. But again, if you set a cookie in JavaScript, then the server wouldn't be able to tell if it's HTTP only or not, because it only gets the name and the value. Last thing I want to talk about is same-site cookies. So this is a recent, relatively recent change, and you might have seen some warnings in the latest Chrome because they're changing the default behavior. So same-site is a kind of a special flag on a cookie because its effect depends not only on the target URL, but also on the source URL. So if one site makes a request to another site, then this request might not include some of the cookies depending on the same site attribute. And so this is basically a security measure against cross-site request forgery attacks. And but the tricky thing here is that, well, how do you define cross-site? What is cross-site request? So when I first heard about it, I immediately thought about same origin policy, right? So most of our other security mechanisms on the web, they operate on this, on origins, which is basically a domain plus port and protocol. And origins are isolated from each other. But as we know, cookie scope is very different, right? So the cookies don't really look at the protocol, they don't look at the port, but they take path into account and domain. So given this, which part of the URL do we need to look at to determine whether a request is cross-site or same-site? So I don't know if it's intuitive for you, but it's actually this. It's a so-called registered domain, which consists of a top-level domain, .co.uk, and one part to the left of it. So as long as two URLs share this part, they're considered same site, which means that bank.com can indeed protect itself from evil.com because this is a cross-site request. However, this is a strictly same-site request. This is a strictly same-site request, and even this is a strictly same-site request. So even though all of these are not same origin requests, which means that, for example, you won't be able to send AJAX requests with credentials in all four of these cases. But things like link navigation and form submissions would actually include all the cookies, including same-site cookies in these three green cases. So keep that in mind if you're if we're going to use the same site for protecting against those attacks. Yeah, so cookies are tricky, and but is there any hope? Right. So Well, unfortunately, as Simon already mentioned, backward compatibility is a problem. So making cookies robust and secure without breaking whole lots of existing cases is very difficult. And while we do see changes, like for example, the same site attribute, it's, well, pretty easy to see how imperfect those solutions are and how clunky and intuitive they are. But what is not so easy to see is that, well, all these decisions, they're actually a result of months of hard work of truly brilliant web engineers. And those people, they have like tremendous responsibility before the whole web community. And if you are interested, there is, of course, a lot of ongoing work. For a short term, you could look at the latest draft for the next RFC. So this one is actually mostly focused on, you know, reducing the gap between implementations and the spec, just like this UTF issue that I mentioned. For like middle term solutions, there is an interesting proposal from the Chrome team. It's called Cookie Store API, and it's basically an asynchronous asynchronous alternative for document cookie. And we might see it in the origin trials, at least in Chrome, sometime soon. And for like more of a longer term replacement, there is an interesting proposal by Mike West, who is actually the editor of the current standard. So this guy knows what he's talking about. It's called HTTP state tokens, and basically he's trying to take the most common use case of cookies, which is sessions, and he's trying to bake it into HTTP with security in mind. So that's interesting. And all this work nowadays, it's all done in public, right? Which means that anyone can jump in and try to make it better and contribute, which, well, I would encourage all of you to do, because, I mean, like, someone's gonna ask why, like, we're going to use it in our day-to-day job anyways. So, and while it's still in development, it's much easier to make changes to it. And if we're going to use it anyways, why not just go in there and, well, trying to make it better for us? And yeah, so I'm just encouraging everyone to just go out there and take a look. I'm sure you will appreciate the web even more after that. And probably the guide that Simon has been talking about is a good start, because, well, I had a look at it, and it's a gold mine of useful links if you're interested. So go ahead and check it out. Yeah, so that's pretty much all I have for today. And I think the only thing is left is a cookie monster that ought to be on every cookie presentation. And if you have any questions, I'm just happy to answer them.
Thanks a lot, Max. Yeah, it's always interesting to hear these corner cases. Some of them are really insane.
Yeah, they are.
The port one always is bizarre to me. So we actually had a question somewhere in the middle of the talk. Why are they called cookies? Do you happen to know offhand?
Oh, well, actually, I'm not sure. I mean,
Simon?
Yeah, maybe Simon would know.
I don't really know, actually. I don't know the history.
I happen to know this one. So the like old school kind of architecture side term, like software architecture term of a magic cookie as some value that is known and is passed unaltered between two parties that are communicating, or saved somewhere as like a stack protector or something like this. Yeah, it's a magic cookie for the web. And so the original implementation called it cookies because it was the same idea on a different platform. So other questions? We don't have any other Zoom questions. for the cookie talk. But what I'm kind of interested in is the like, what has the Chrome team proposed for their cookie store API? Is there anything like fundamentally different about, other than the asynchronicity and the, I don't know, more modern API? Does it change the way that the cookies are sent back and forth, or how does all this work? Is
Yeah,
it just
that's a good
browser
question.
API?
Thank you. So yeah. So basically, this is why it's still controversial, that proposal actually, because so what it's trying to do is trying not to change the security model of cookies. So it's mostly a replacement for existing document cookie mechanism, but it's asynchronous. So, and it's inspired by local storage and session storage. So you could like subscribe to some events, or you can set and get values, and but it doesn't aim to change the security model. So all this weak integrity stuff is still there. And one more thing that it's adding support for service workers, and because right now it's a little difficult. So I think it's actually one of the main goals to support cookies. And right now you can do this, but you have to make hacks around it, like with iframes that redirect weirdly to something else. So you can already do that, but it's just so inconvenient. So they're kind of trying to codify it and make it better. And of course, performance is another reason, because the current API is quite well, it can introduce junk because it's synchronous, and a synchronous API would solve this problem.
Thank you. I now see, I didn't scroll down, so I was missing a couple of the questions that we had in the Zoom Q&A. So the first one's actually something you just mentioned, which is a question by Peter. It sounds like cookies are almost dangerous. Is there any thought of deprecating them in favor of a more predictable mechanism? And Peter suggests brownies. But yeah, this is the same idea. You said that if the Chrome cookie store API doesn't change the fundamental security model, is there another proposal that does?
Yeah, well, not that I'm aware of, because I mean, cookies are tricky, but they're so fundamental to most of the interactions on the web right now. So they're not going anywhere anytime soon. And while there are those proposals, like this HTTP state token is interesting, but it has its limitations, and it's just a proposal. So I don't think we'll see it in the coming years, I think. Yeah, so we're still good with the cookies. And of course, like my guess is, well, probably Simon would know better, but my guess is if we go forward with that, then it will probably be something completely new but the cookies will still be supported, and new applications might start using something, well, more structured, so to say, more secure. But yeah, the cookies will not be replaced for a long time, I'm afraid, like completely.
Yeah, I think that's right. I think that people can do to have a stricter subset of cookies is to use the same site. I think strict is a value that you can apply for the same site attribute. I don't remember exactly what the behavior is, but
yeah, that's right. And so browsers seem to be also making steps towards it. So for example, its latest changes with same site, so default behavior of same site cookies, of same site attribute and cookies inside Chrome will be different. So it will be lax by default, which is not the not the most relaxed. Yeah, so I guess the biggest problems with cookies right now is this tracking and all these vulnerabilities that you could have. And so they're kind of trying to tackle the most critical issues with cookies by introducing these kind of things. So the same way HTTP only and secure flags were added back in the days, just like as a backwards compatible change that would still allow to, well, you know, protect the most critical cases. So and this is the whole thing. I think about the modern webs, that it's just it has a pretty long list of old protocols and mechanisms that we can't just drop.
Yeah, don't break the web.
Yeah.
So we have two other questions. We're getting close to time, but they're both really good. So the first is from Ishta, who asks if there are any tools are there any tools to find out if the way we're setting or using cookies in our domain is exposed to vulnerabilities or exploitation?
Well, this is tricky because, well, actually, DevTools is, with regards to same site, Chrome DevTools are already making warnings. But in general case, the thing is that it depends, because what is a vulnerability for one cookie is not a vulnerability, is a feature for another one. So for example, if your goal is to track a browser across different domains, then, you know, exposing this cookie to third-party cookies, third-party domains is okay, and that's actually what you want. But if it's not your goal, so it depends on the semantics of your application, I guess. I mean, of course, the general guidelines is that, well, use the strictest settings as possible, like use HTTP only if you only need it for the backend. Or use secure all the time if your website is only talking HTTPS, which it should. So these kind of things, and use same site again for by default. Maybe use same site strict unless it's needed. So I think that's the best way.
Yeah, I don't have experience using tools to check for cookie vulnerabilities. But I just Googled, and it appears that there are tools that's try to find problems with cookies. So if anyone has experience with any of them, please share.
Well, I do actually have experience with, like, I'm not sure if this is what you found, the like security scanners, but they're pretty generic. Like, so what the best thing they can do is they have this database of commonly used cookie names. So for example, I know Django is always using you know, CSRF cookie as a name for CSRF cookie. And so it just knows that, and if it sees that this cookie is, you know, exposed or has a very long expiration time, it would just bring a warning. So that's like the most useful result that you can get. And of course, you can have like the low priority issues for like cookies if they don't have HTTP only, but they seem to be transferred only with HTTP or something like that. So yeah, like this kind of checks you can do with automated tools. But I think at the end of the day, it will probably just come down to your particular application.
And we're got to keep it kind of short for this last one, but there's a question from Moritz asking if cookies are so complicated and so many legacy issues, should you use local storage where applicable, also for secret values?
Oh, well, if you can, if that actually satisfies your need, I would say go for it, because not only it will be more performant because the local storage contents is not sent with each and every request, and with cookies it is. And actually, we've seen literally megabytes of cookies in a single request. It's not uncommon. But so it's of course it's very bad for performance. But yeah, like cookies are still sometimes needed. So for example, for session cookies, you can't use local storage. Well, I guess maybe you can come up with some kind of mechanism, but it's just not very standard. And simple cookies like session cookies are totally fine because they're usually small and sufficient.
One aspect for local storage and how they differ from cookies is the scope. So local storage and the other storage APIs use the same origin policy.
Yeah.
So they don't use the weird cookie scope.
Yeah, which is, I would say it's a good thing actually, because it's it kind of plays well with all the other, like with cores, for example, and stuff like that. So yeah, but there are fundamental differences, of course.
Tomas on YouTube asks as a follow-up, isn't local storage more vulnerable to cross-site scripting?
I wouldn't say so. Like if you have cross-site scripting, it's not, I mean, there's a lot of other things you could do. Of course, you would go for cookies most of the time. But yeah, like it's a tricky question. By itself, it's not, because you can, if you have access to JavaScript scope, you can read both JavaScript cookies and local storage. And if you don't need something that, if you don't want to expose some data to client side at all, then why using this at all? You could just store it on the server side in the session storage or something like that. So I'm guessing that if you do use local storage, that means you do want to deal with this data on the client side in JavaScript. And most of the time, actually, I would argue that nowadays, most of the time, the things that you would store in local storage would be, well, quite large for setting in a cookie. So yeah, I think.
Nice. Yeah. Very good. Well, thanks for the answers. Thank you for the talk as well. Super entertaining. And yeah, it seems like it generated a lot of interest with the good questions. So very nice.
Thank you for
I want to point out I want to point out two things that Simon posted to the Zoom chat. One is the WPC guide, which is a book released today, right?
Yes, we just released it before this talk.
Yeah, literally today. So you can check that out. That's at wpc.guide. And then he also mentioned a web.dev link for a bit of an explainer for same-site cookies, because that had come up quite a few times in the discussion. Very good. Okay, so I think, let's see.
The fun stuff.
Yeah, so now we have the web platform test. And for this, I'm going to...
Quiz.
Yes, quiz, not a test. The web platform test is much more rigorous than what you're about to get. But yeah, so this web platform quiz was really popular last time. But yeah, this is Max's baby. So I'm going to maybe give it over to Max.
Well, I did have some help from my friend Dima. But yeah, let me just share the screen again. So for everyone that's who's still with us, if you want to participate, please go to this URL, the myquiz.org, and enter this game code 344864. I have this right here. So yeah, I see that it's reflected on the stream. Yeah, so what is this? This is a very short quiz. It consists of 10 questions. And since it's a web platform quiz, the questions will be about all things web platform. So there will be questions about HTML, CSS, HTTP different web protocols, JavaScript, and they are framework agnostic, and about security also. So kind of all around web platform. Each question will have 1 or 2 correct answers that you will have to pick. The time will be limited, and so the scoring works this way. So of course, the more correct answers you submit, the better. But if we have like sorry, if 2 people score the same, then the first one wins. So the speed also matters if you're should be quick enough. But take your time. It's better to answer correctly than quickly. And after each question, there will be, of course, the correct answer will be revealed immediately with some short explanation. So I see 13 people joined already.
I want to point out also, you can do this from your phone.
Oh,
if
yeah.
you're watching just on the couch
absolutely.
with YouTube, you can totally do this for your phone. So just go to the link there with the code. And if you put that in, then you'll go right through. The YouTube delay is not very long, so you should be able to just go along right with it. And also, there is a prize.
Oh, yeah.
You ship it internationally.
Yes,
so,
thank you.
It behooves you to...
Should I say what the prize is?
No, you should not.
I should not.
Maybe you can reveal it after the quiz.
Maybe, yeah.
It's okay. Very stylish, we'll say that.
It's a nice prize. I mean, any prize would be nice, right, guys? Come on. Yeah, so 16 people joined, and it's been like this for like half a minute already, I think. Let's just give it a
little longer in case YouTube people are jumping in. We got 10 of them.
So each question will be different in time. I think the longest is 90 seconds. The shortest is like 20. So try to be quick. Okay, so it's 16 and it's not growing. So shall we just start?
Yeah, let's go.
All right. So here we go. 3, 2, 1, go. The first question is CSS. This code here, we can see the div rule and with some colors and then some media queries inside. The question is, what will be the color of the element on a 130 pixels wide screen?
Those answers are coming in very fast.
People 13, 15, 16, everyone answered. Cool. So let's see the results. Nice. So 12.5% of people answered blue, and this is the correct answer. So the tricky thing here is that these media queries are nested, and in CSS, in native CSS, you actually cannot nest this. So this is a not valid CSS. So this would be ignored, and just the color blue will be effective. And there is the syntax highlight is kind of hinting here. Interesting thing is that you can actually nest media if you're using SCSS or SAS. So that might have confused people. But SAS compiles it to a top-level media rule. Okay, 7 seconds till the next question. Question number 2. Which of these tags is not a native HTML tag? Only one of them is not, and all the others would be understood by the browsers. 3 seconds to go. 1, 0, and yes, 31% of people answered correctly. It's container, so this is a non-existent tag. Ruby, I would answer Ruby totally. And image is actually, let me pause it for a second. Image is actually not, well, not an element. So it would be replaced by browsers to IMG, but still they would handle it.
Hey, Max, what's a Ruby tag?
Well, it says here something. It has to do with Ruby annotations for East Asian characters. I'm not actually sure what that is.
Yeah, when you have East Asian characters and you need to spell them out because they're like individual ideographs, you can put their spelling in smaller characters above them. I think
Okay.
that's Ruby, right? Yeah, Simon is nodding. Okay.
Yeah, that's right.
Yeah, Simon is HTML expert here.
Yeah, I'm looking at him in case I'm not sure and just seeing how his face looks.
And yeah, we have the leaders. We have 2 leaders who got 8 points actually, Foobar and Yoop, or I think it's Yoop. Okay. Question number 3. Well, if you listened carefully to my talk, you would know this. Can foo.example.com set a cookie with the domain attribute set to bar.example.com? Let's see. Okay, and the answer is yes. Yeah. Well, I will be publishing the slides as well. So for those who answered no, that's totally fine. Question number 4. Which of these iOS Safari features was implemented most recently? So all of these are supported by the latest iOS Safari, but only one of them is the latest. Service workers, Shadow DOM version 1, CSS grid, and iframe scrolling. Let's see. Oh, wow, I'm actually surprised. 37% of people answered correctly. That's a good thing. So the iframes, for those who don't know, iframes on iOS, on iPhones and iPads, up until version 13, exclusively, they were forcibly expanded. So you couldn't have scrolling iframe elements on iOS, and they only implemented it together with iPadOS. So now it's fine. Next question: which generic top-level domain has a language restriction? So all of these domains, dog, cat, duck, fish, and fox, they're all real top-level domains that are on the web, but only one of them has a language restriction. So which one? And the correct answer is cat, and 26% of people answered correctly. So in order to use the .cat, you have to publish some content in Catalan language, and that's the restriction. So someone named Nickname is the leader right now. So well, that's a creative nickname. And Foobar is just 1 point behind. Still have 5 questions to go. Okay, the first JavaScript question. And this is a tricky one. That's why there's a lot of time. We have two functions, first and second. Both of them are trying to execute eval. And the first one first assigns eval to some local variable and then tries to execute it. Second one is doing the same, but then using that variable as a context with statement. And both of them are trying to console log a local variable that is declared inside this function. So which one of these functions will execute without errors? Only first and the second, neither of them, or both? 11 people. Yeah, people are hesitating, thinking. It's a very difficult question, to be honest. I wouldn't be able to answer that if I didn't know. Okay, 3 seconds to go. 2, 1, 0. One person didn't make it. Yay! So the second, let me just pause it right here. So the second is correct answer because there is such a thing called indirect eval. So and it's pretty tricky, but in the first case, this would be considered indirect eval. So this code here would be evaluated in global scope. And of course, in global scope, you don't have variable because it's declared inside this function. So this would fail. But the second one, weirdly, would not be considered an indirect eval because, well, pretty much because it looks like eval and not some other function. And this one would work just fine. So this is one of the, I guess, dark corner cases of JavaScript.
It's so wild to me that the actual name of the identifier that it's assigned to matters.
Yeah.
Like even if it's pointing to the same function object, it doesn't.
Okay.
It's important.
Yeah. Sorry to interrupt you. Next question. Well, this is an easy one actually. Which of these protocols are supported by the latest Chrome? Speedy, ALPN, BLST, or Quick? Or and there are, I believe there are 2 correct answers here. So even if you guess only one, that you would still get some points. And the correct answer is ALPN and Quick. So Speedy, well, I understand why people were confused about Speedy because it was implemented in Chrome, but when they introduced HTTP2, they actually removed it. So nowadays it's only HTTP2, and LPN is an SSL level protocol that's used by HTTP2. So it's there. And Quick is, oh, okay, so we go to the next question. Which attack is not applicable to HTTP2, speaking of HTTP2? Only one of these is correct. And we have some very shady hacker on the kitchen. Yeah, so cross-site request forgery, HTTP response splitting, server-side request forgery, or referrer spoofing. And most people got it right. It's HTTP response splitting, of course, because because the response splitting is actually relying on text nature of HTTP1. So HTTP2, it doesn't make sense. Another JavaScript question, another tricky one, proxy objects. So we have a proxy object which overrides has method and the get method. And then we use that proxy object again with what's the with expression, and we're trying to do console.log inside that block. So yeah, and has implementation always returns true, and the getter always returns a static string in this case. And the question is, what's the result? So basically, what will be outputted in the browser console, or in, I think it's also working in Node, I guess, right? So just in console. Let's see. Okay. Yeah, so the correct answer is it will give an error. and 13% of the people answer correctly. So the thing here is that inside this with block, all the top level globals will be first looked up inside the proxy object. And in this case, proxy object reports that console is actually in there. So the getter would return a string. So console would evaluate to this proxy text string. And of course, string doesn't have a method called log, and that will cause an error. So I believe it's going to be the last question now. Yes, and this question was kindly donated by Simon. It's actually right from his book about HTML parser. What will be alerted here? We have a small HTML snippet with seemingly a script tag, and then with alert statement inside. But this alert statement has something that looks like an HTML comment and another script inside. So it's tricky. What do you think will be alerted? Nothing, empty string, X, or the whole string? And the correct answer is this. And most people got it right. Good for you. Yeah, there is a very long explanation about it. So the HTML parser apparently tracks all of these internal states. And there is a link here to the book, which explains it in detail. And with this, we have a winner. So I think it was just the last question that got full bar the first place. Good job. So whoever you are, well, actually, we didn't think it through. How are we going to? Well, so let's just reveal the prize here, right? So the prize for the quiz, for the winner, will be a T-shirt, pretty much like I'm wearing right now, and a few smaller presents in the package. So, well, I guess I'm going to, we'll have to just rely on your honesty, guys. So Fubar, Mr. Fubar or Miss Fubar, please contact us at orgs@webcore.group, and well, we'll figure out how to send you a prize. Congratulations. Yeah, so I think this is it for the at least for the quiz. Right, Quint?
Yes. Okay, my mic is on. Great. So it was super nice having everybody here, especially from all over the world. So yeah, thanks a lot for joining us on Zoom, on YouTube. You can find future WebCore events at webcore.group. On there, there's a link to the meetup, and if you join that meetup, then you can attend specific events. So we'll have some combination of physical events and virtual events going forward, and we're going to do our best to stream the physical events so that people can attend remotely that way. We prefer the physical stuff just because it's nice here to be able to chat with people locally. But yeah, we'll do our best for the remote attendees. I'd like to thank our our speakers, Simon and Max, for giving such interesting deep dives into the rabbit holes of the web. We'll publish the videos from the individual talks, so those will be separate, hopefully without the kind of front matter of us figuring stuff out, just the juicy content. And the slides will also be published. Simon has added some links to the slides and books and a couple other good things in the Zoom chat. We'll make sure that those are also available in the YouTube description for YouTube for the individual talks, and then also our page, the meetup, and anywhere else that you can find us. Spread the word a bit about WebCore. We just do this for fun. It's a mystery why our boss even lets us. So it's super nice. And this is really a kind of unique opportunity to talk about these kind of core web technologies. There's not many other venues for it. And yeah, so yeah, thanks everybody for joining. Anything else to add, anybody?
Yeah, I just also want to thank everyone for joining us today. This is our first try on the online, like fully online events, and we will, as Quinn said, we will do it more. We will also do offline events, but we're still figuring it out how to combine it with online presence, because we do want to invite more international speakers, because there are just so many great engineers out there who are ready to give a talk. And yeah, so to keep in touch, just join our group on Meetup, subscribe to our YouTube channel, and yeah, so just let's keep in touch, and we'll see you next time. Thank you very much.
Cheers.
Yay.
Thanks, everybody. Bye-bye.
Bye, everyone.